Today we're going to be talking about empirical formulas. So let's define what an empirical formula is first. This was at the very end of chapter 10. So whenever you did your outline, you probably didn't find any stoichiometry in chapter 10. You found some ways to convert to moles, but one of the things that I guess I kind of skipped ahead and I forgot that stoichiometry was in a different chapter, but that's okay. We've already learned how to do it, and we're going to learn some more to add on to it. But empirical formulas is something that we honestly cannot skip. It's a skill that you've got to know. It's just part of knowing some chemistry-related skills, and so we're going to learn how to calculate an empirical formula today, okay? So let's define what an empirical formula is. An empirical formula is the simplest whole number ratio of elements in a compound. The simplest whole number ratio of elements in a compound. Okay, so if I look at, say, C2H6, is there any way we could come up with a simpler formula than C2H6? Could I divide both of those subscripts by something and end up with a simpler formula? Okay, so a couple of you are shaking your hands. We could divide that by 2, or nodding your heads, rather. And so this would end up being CH3. And we see that we could simplify that formula. So CH3 would be considered our empirical formula. Now, C2H6 is called the actual molecular formula. So let's define that, molecular formula. The molecular formula is the actual formula of a compound. So if I looked at C2H6, it's like, oh, okay, I can simplify that. That would be my empirical formula, but C2H6 is what the formula really is. Okay, now let's say that I had H2O. We know that that's the actual formula for water, right? H2O, water. We know CO2 is the actual formula for carbon dioxide. But can we simplify those formulas and make them into a smaller whole number ratio? Can we make them simpler than that? And still have whole numbers is what we're looking for. Don't be afraid to fail. That's all right. Don't be afraid. Can we make it simpler?
Yes.
How can we make it simpler? What can we turn H2O into and still have a whole number? If we divided H2O by 2, we would have H oxygen 0.5, right? Because right now we have 1 oxygen. So what I'm trying to get you to see is sometimes the molecular formula is the empirical formula, okay? You may not be able to simplify that. So in these two cases, the molecular formula and the empirical formula are the same thing, all right? Now, who really cares about simplifying a molecular formula? The only reason that we need an empirical formula is we use that to find the molecular formula. So we work kind of backwards here from what I taught you. We go from the empirical formula to the molecular formula. Okay, and that's what we're going to look at. We're going to look at some math problems today to determine how to determine what the true molecular formula is for that compound. But first, we have to find the empirical formula. All right, we're going to work a couple of problems from your assignment today. So let me pull those up real quickly. Sorry, shouldn't have that up. Okay, so in our practice problems that we have, this is on a Google Doc. So if you're like, I can't get it opened, then move around in the room. The Wi-Fi has been a little sketchy lately. All right, we're going to look at question number 2 together. Okay, so right now, you guys that are close up, Real, I know I asked you to read a lot, but do you mind reading that question out to us? Number 2, yes, sir. And while he's reading that out loud, you guys go ahead and be writing down the information that he's calling out, okay?
On the empirical formula for combined group, 21.8% magnesium, 27.9% phosphate,
Phosphorus.
and 50.3% phosphorus.
Okay, so our job is to come up with the empirical formula for this compound. This is what we know, okay? So we're looking for empirical formula, don't know, and we've got the compound is made up of 21.8% magnesium, 27.9% phosphorus, and 50.3% oxygen. That's what we do know. Okay, so before we can do anything, we have to get rid of these percents, okay? Your very first step is if you have percents, you're going to need to change your percent directly to grams. And a quick and easy way to do that is just make an assumption. Assume that you have 100 grams. If I had 100 grams of this substance, how many grams would be magnesium? 21.8. And 27.9 grams would be phosphorus, and 50.3 grams would be oxygen, okay? They didn't tell us how much we had, so we can just real quickly make that assumption. So all I'm going to do then is just cross off my percents, and instead of having percent there, I'm going to change that to grams. All right. When you are dealing with things in chemistry, honestly, we can't do anything with it in grams because different atoms have different sizes. And in order for us to compare one element to another, we have to get it out of grams and into our common unit. What is that common unit that we tend to convert everything into? We go from grams to moles. Good. All right. So that's our next step. We're going to go from grams to moles. And when we go from grams to moles, we divide by the molar mass, all right? So we're going to need to be looking at magnesium, phosphorus, and oxygen on our periodic table. Hayden, I want you to grab magnesium. You're looking that one up off the periodic table. Vicente, you do phosphorus. And Mary Kate, would you look up oxygen? And while they're doing that, we're just going to go ahead and set up our little conversion factors for each one of our elements so that we can convert those into moles. All right, Hayden, you had the first one? I think you checked manganese, so look up Mg, number 12. There we go. Okay, so 1 mole of Mg weighs 24.31 grams. All right, phosphorus, 30.97. And last but not least, we have oxygen, 50.3. Let me write this down real quick, Mary Kate. And how much does oxygen weigh? 16.00. Okay. And I'm just, there we go. We can put the 0.00 there if we want to. All right, so let's get our calculators busy once you get that jotted down so you'll have your example. And don't leave your calculator on the table once you're calculating these. Because if you don't calculate, then you end up under not knowing what's going on whenever it's your turn. Okay, so let's start off with the first one here. Patrick, when you get your answer, share the first number with us, magnesium. JQ, when you get your answer for phosphorus, I want you to share that one with us. And Haley, when you get your answer for oxygen, share that one with us. Okay, everybody else is calculating on your own. You're just dividing.
0.89.
0.89. Let's go out one more digit there. 896. Okay, good. When you're doing these empirical formula problems, it actually doesn't hurt for you to go out several digits. I know we talked about a lot about significant figures, but you'll get a better whole number. It's going to be easier to see if you'll go out several places. And now we have 3 significant digits in our initial number, so I was trying to get Patrick to go ahead and go out a little bit further. Now this is moles of Mg, okay, and who had the next one? JQ, you had the next one? 0.900, and that would be moles of P. All right, and Haley, what'd you have for the last one? 3.15, okay, and this is moles of oxygen. Okay, now if we wanted to, we could go ahead and write our empirical formula at this point, except the definition says that we have to have whole numbers. And do we have whole numbers right now? Is that a whole number? No, that's not a whole number, and neither is this. So our next step, and we'll just put this up here in our little sequence of steps, is once we get everything into moles, we're going to divide all by the smallest. Okay, and so our step is to get whole numbers. That's what we're trying to do. Okay, so you're going to go to moles, and then you're going to get everything into whole numbers, and the way you're going to do that is just divide every one of those numbers by the smallest of, in this case, 3. Okay, so which one of those numbers is the smallest? 0.896. We're going to divide everything by 0.896. When you do that, notice dividing a number by itself, obviously you're going to get a whole number for that one, right? Okay, and we're going to divide this one by 0.896, and I think that's going to be approximately 1. I think it's 1.05 when you do the division there. Somebody do that real quick and let's see what that is. 0.9 divided by 0.896. 1.004. Would y'all call that close enough to 1 to call that 1? Yeah, okay, so that's about 1. And then we're dividing this one by 0.896. Ian, what did you get? You didn't. 3.51. Okay, now we have whole numbers for the first 2. Would y'all agree with that? But the last one, we still don't have a whole number. So we're going to need to do something in order to get all of them in whole numbers. So most of the time, you'll end up with whole numbers right here after this step. But if you don't, then you're going to need to multiply all of your numbers by something so that they all end up as a whole number. This is the only one that's giving us problems right now, right? 3.51. What could we multiply that number to end up with a whole number? Say again, Reese? 100? Okay. What's the lower number we could multiply that by to get a whole number? 2 would be a better answer. What is 0.5? Isn't 0.5 a half? That's really like 3.5. So if you understand what that decimal is, I can move this up there. If you understand what that decimal is, that's 3.5. You just multiply by the denominator, okay, of your fraction. So if I multiply this times 2, that's going to give us a 7. But if I multiply one of my numbers by an integer, I have to multiply them all because we're looking at a ratio between these. So this one's also going to be times 2. Bless you. This one is also going to be times 2. So now we have whole numbers for everything. Okay. All right. Last step is to, and I'm just going to put here, write your formula. Sorry, y'all can't see that. Write empirical formula. So once you've gotten whole numbers, what do those numbers actually belong to? This 2 belonged to Mg, correct? This 2 belonged to phosphorus. This 7 belonged to oxygen. So our formula is going to look like this. Mg2 P2O7. There's our empirical formula. Okay, now we're going to work one more, okay? Just make sure you guys have this. And remember that the whole goal on this was to get a molecular formula. We have to get an empirical formula. in order to determine the molecular formula. Yes, Hayden? Yeah, right down the steps. You want me to pull that back up? Okay, so here are steps. If you want to jot those down, I'm going to keep those up while we're going through this next problem. So as Hayden's writing down those steps, let's just kind of review them. Okay, so if you have a percent, you're going to immediately go to grams by making a mental assumption that you have 100 grams. Okay, so that's the easiest part. What if you already start out in grams? Do you worry about it? Nope, you just move on. You're at that step, move on to moles. Okay, you'll find some of the problems that you're working today will already start in grams, and don't stress it. That just means, oh, that's just a little bit easier. Okay. All right, and so from grams, you're going to go directly to moles by dividing by the molar mass of that element, okay? And if you notice, hopefully, these are easier than the problems we work with stoichiometry because we're only dealing with one element, right? Not a whole huge compound where you're having to add up the molar mass. Once you get things into moles, you're going to divide everything by the smallest of your moles, okay? And that's going to allow you to get whole numbers. Now, there was one kind of, I guess, segue step. If you didn't get whole numbers, you've got an example to look at of what we ended up trying to do to get whole numbers. So we had this one that immediately didn't give us whole numbers, so we had to multiply by some integer. Okay, you won't have to do that every single time. Most of the time, hopefully, you should end up with getting whole numbers just by dividing by the smallest. All right, and then your last step is to write your formula, write your empirical formula. Okay, so I think what we're going to do is we're going to work number 5 on our sheet. Gentez, you got all these? Got the steps written down? Okay, awesome. You have a calculator handy? Okay. This was number 2, yeah. And if you want to number, because we'll kind of work them out of order, but you guys are going to work 1 through 8 today. Okay. All right, you good, Hayden? All right, so let's look at number 5, I think is the one I want to work. Yeah, number 5 is a good one. Okay, so Reese, your turn. Would you read out number 5 for us? Okay, so let's write down everything that Reese read off for us. Now, we've got an extra little piece in there that we didn't have in our last problem, and I'm going to switch over so you guys can see what I wrote down. Okay, so here we go. We have 92.4% carbon, 7.6% hydrogen, and then our molar mass, MM, is 65.10. Okay, we're going to hang on to that until we get our empirical formula found. So your first step is always to find your empirical formula, okay? And then we'll go back and we'll use that molar mass to find our molecular formula. So think alphabetically. Empirical formula starts with an E, right? And then molecular formula starts with an M. You've got to find E before M. All right, what's our first step here? We've got things in percentages, so we're going to do what with those? Just get rid of them, change it to grams. Just mark them out. Okay, and so now we're here at grams, and our next step is to divide by the molar mass, right? Okay, so let's see. Gracie, would you look up carbon? And Kyler, you grab hydrogen off the periodic table. All right, what do you have, Gracie, for carbon? 12.01. And Kyler, what do you have for hydrogen? 1.01. Very good. Okay, so let's do our math. Justin, when you get carbon's moles, tell us what you got. Gunnar, when you get hydrogen's number, tell us what you got. The rest of us are calculating on our own. Okay. Oops, it's moles, not grams. Okay, so whoops, messing up with my pen today. Okay, so we've got two different numbers here. We are to moles, and now our next step is to divide everything by the smallest. So of these two numbers, which is the smallest? 7.52. So we're going to divide both of them by 7.52. It's going to give us a 1 for the hydrogen, and looks like approximately 1 for the carbon, but go ahead and throw that in your calculator and see what you get. 1.02. So that's close enough for us to call that a 1, right? All right, so our last step, we have whole numbers, so we don't have to do anything extra there, and we're going to write our empirical formula. So we have 1 carbon with the mass. Where are we going? We did. We divided 92.4 divided by 12.01. No. Oh, we're going to. We're going to. But first, we have to find our empirical formula before we can do anything with that. That's a good question. I'm sorry about that. All right, so here's our empirical formula, CH. Okay, so now our job, they gave us a little bit more information. We can find the true molecular formula. Okay, so we found the simplest whole number ratio. We're going to take our molar mass that we have, and we're simply going to divide by our empirical formula mass. And so how do we get the empirical formula mass? We have the empirical formula. How are we going to get its mass? Add the two up. That's right. We have 1 carbon, 1 hydrogen. Okay, so 1 carbon weighs 12.01, right? And 1 hydrogen weighs 1.01. So add those two numbers together. 13.02. So that's going to go on the bottom. And that's again in grams per mole. Notice that grams per mole, those units would cancel out, right? And so you're not going to have a unit when you finish this division. So divide that out. Let's see what you get. 5. Okay. And that's what we're wanting, a whole number here. And actually, if you do everything right, I've never seen where you don't get a whole number. All right. In all the many problems I've worked, you're going to get something that's going to round to a whole number. What if you get 4.98? Is that close enough to round to 5? You bet. Okay, so what are we going to do with that 5? We use it to write our true molecular formula. So our simplest formula was CH, okay? And so now we're just simply going to multiply 5 times the CH. So our new formula, or our true formula, is C5H5. That is our molecular formula. All right, so what did we do here in the last step? This was the last step that we did, right? You only do that when you're given the molar mass, okay? You don't have to deal with that if you aren't given the molar mass to find the molecular formula. But in order for you to find the molecular formula, you have to have the empirical formula, okay? So either you're going to have to find it or they give it to you. There is one problem I know for sure, that they give you the empirical formula. So you just go straight to here and take the molar mass divided by the empirical formula mass. All right. Are we good? Got enough information to roll out some problems here? All right. You don't have a lot to do because we just did 2, and you're only going to do 1 through 8. Okay. There is a second page on this. That we will talk about how to do those problems next time we are together.